Hello everyone, welcome back. So today we are gonna cover our rest of the directories that are left. So we are gonna cover /dev, which stands for /device, /proc, which stands for process, /sys, which stands for system, and /mnt. So let's start with /dev. So /dev stands for devices. It contains a device file that represents hardware and virtual devices. So everything in Linux is treated as file, including hardware. So why does /dev exist? So /dev exists because it allows program to communicate with hardware very easily. It provides file-based interface to devices, which is incredibly useful for us to configure if something is broken. It makes hardware access consistent and secure. Example, writing to a device file means sending data to a hardware. Reading for a device file means receiving data from hardware. So before we go more into a file structure of /dev, there is an important concept in /dev, which are block devices and character devices. So when you want to send data, so for example, if you want to send data to a speaker, right, you don't need any APIs. So what you can do is you can just write data to a file in /dev that represents the speaker. So there are two types of file in /dev, which is very important concept. They are character device and block device. So character device means data is sent one character, which is one byte at a time. Think of it as your keyboard or mouse, right? And block device is data is moved in large chunks. Think of it as your hardware or a USB stick. Okay, so difference between character devices and block devices are we can differentiate it by go to your terminal, right? Once you go to your terminal, type a command lsblk. Once you do this is our block device specialist. So if we want to understand block device, before moving to that, just do ls/dev. We'll see the files that are inside /dev. There are multiple files, like there are null, there are loop, there are sta. So these are block devices. Okay, so these are the go-to command for block devices. What it does is it ignores the messy characters and only shows you the storage hardware. Okay, so it shows you the tree. So what it does is it shows us our hard drive, the partition, and where they are mounted in our system. So it is used for that. So what we are going to do is we are going to do lsblk. So once we do this, right, we are going to see a bunch of lines. So we'll see loop 0, right? We'll see loop, we'll see snap/bar, which is our mount point. So what are these? So let's understand. So the most important part is this SDA. So SDA, this is our actual hard drive or a SSD that is being used in a machine. So SD1, as you can see, this is /boot/EFI. So this is a EFI partition. That means it is an ignition switch for your computer. When you turn on your machine, right, when you turn on your computer, the motherboard looks here to find instruction on how to start a Linux. So it's basically used for that. And our SDA2, here you can see a slash. As we know, slash is our root directory. So everything, our /bash/usr/etc., everything lives inside our root. So it's basically for that partition. So another one is important. As you can important is loop. So as you can see, there is from loop 0 to loop 30 actually. So this is not your actual real physical hardware. In Ubuntu, these are the snap packages. So like you use Firefox, you use debugger, you use Google Chrome, right? So they are actually stored over here as a compressed disks. So when you run these application, right, Linux mount the compressed file as if it was a physical drive, so it can read the file inside them. So it's basically used for that. So every single line you see, like /dev/sda/dev/loop, so everything, these are our block devices. So in order to check if our sorting command is block or character, what we can do is we can write this command. We'll do ls, we'll do -l, which is for long list, and we'll do dev, we'll check for SDA. okay, so as I've told you, SDA is your actual physical hard drive or SSD. so as you can see, it is brw -rw1, so it starts with B, so this means it's a block, device. So basically it is that. So now let's move to the file structure in our /dev. So there are some special devices which are in our /dev. So one of them is our this null. So /dev null, so this is basically called a black hole. Anything you send here disappears. It is used for silencing unknowing programs. Okay, for example, what you do is, if you do ls existent folder. Suppose this is our non-existent folder, right? So if we do this, then it basically throws the error. But what we can do is, we're gonna do this. So two arrow is basically 2 is standard error. So what we're gonna do is dev, let's give a space, dev /null. so we are going to send our this command to our /dev null. So see, nothing happens. So what happened is, it is redirecting to /null, and it is discarding everything. It is discarding the error. So that's why we don't see any error in our terminal. So another special devices in our /dev are 0. So this file provides an infinite series of null character zeros. Suppose what we can do is, we're going to use command head -c 100 /dev. we are going to read a 100. See, we're going to do 0. okay, and xxd. so xxd, so basically what happens is, you'll get bunch of zeros. So the command reads the so what happened is, the command reads the first 100 byte from dev /0 and shows them to you. So this command means so that command means this, it is giving you 100 it gives 100 byte from dev /0 and is showing you. So everything here is 0, right? It is. So what is the purpose of this is, if we have to create an empty file of a specific size, then we are going to use this command. So that's the use of dev /0. another special file is dev /random and urandom. So so as you can see, urandom and a random. So these provide random number. So most of the time we are going to use dev /urandom, as this is it is easy to use, and Linux automatically uses this then our dev /random. So it is used to generate a random password. So basically let's, for example, we can do cat /dev urandom. okay, so what we're going to do is, we're going to translate, delete and only keep the character from a to small a to small z, big A to big Z, and our from 0 to only 9. So let's do this, and again what we're going to do is, we're going to fold the width to 12. okay, and only so, and stop when you reach line 5. So it's basically what we are going to do is, we are going to generate. So see, we have generated 12 word password from our urandom. So basically use of urandom is to generate a password, but there is difference between urandom and dev /random. okay, so in older Linux there was a huge difference. Dev /random, it only gives you random number when your PC has enough entropy. So entropy means a physical noise from your keyboard or a mouse hardware. So for example, if you ask for 100 random number, and if there is no enough entropy, right, then your PC stops. But in our dev /urandom, it uses a mathematical algorithm. It is also known as pseudo random number generator. It uses a mathematical formula to generate a random number. It generates random number even if no enough noise is there in the PC. So why do we use dev/urandom more? Because modern math has proven dev/urandom is just as more secure at almost everything, including password and encryption, and it never makes your computer wait. So when do we use our dev/urandom and random? So what we just did earlier is we created our password manually, right? But what our machine does is it uses this almost every time without even telling you. Okay, so it is mostly used during encryption. So every time you visit a website, you're visiting Google or you're visiting a Reddit, anytime you visit your browser generates a secret key so that hacker can't see your data. So when you are visiting them, the PC asks for dev/urandom to generate a random number to start encryption. So basically it is used for that. Another is for the security shuffle, to prevent hacker from predicting where a data is stored or where a program is in RAM. Okay, it shuffles memory location every time you run an app. It uses dev/urandom to decide the shuffling order. Another is when you make a file or when you dix a partition. Okay, when you partition a dix, a unique ID is generated every time. Okay, the random number are generated from urandom. The unique ID is generated from urandom or random to ensure no two file has the same ID. So basically it is used for encryption majorly. So we are gonna use a command. We are gonna see how much our computer has a random power. So for that, what we're gonna do is we're gonna do cat hyphen. So we're gonna see how much our PC can generate a random number. So random entropy available. So basically we're going to see how much entropy is available for our PC. So mine is 256. If you see a number 256 or 4096, your system is noisy. That means it is enough to be very secure. So but if you see lower, then that's a red flag. So but in modern PC, in our modern Linux, what happens is u/random and dev/urandom and dev/random they are both equally faster. So let's check the speed. So what we're going to do is dd, this is a duplication command. If file equals to, if means input file, dev/urandom, we're going to check the speed of urandom and we're going to send that to our dev/null, our black hole file, and our block size would be 1 MB, and we're going to do till we're going to do till 10. Okay, so as you can see, it took 0.05011097 seconds. Okay, what we're going to do is we're going to check for our dev/random. Same command, just use random instead of urandom. So see, there's not much of a difference, because what happens what happened in our modern Linux is our modern CPU have a feature called RDRAND, a tiny piece of a hardware inside our processor that generates a random number at incredible speed. Okay, so Linux use this to keep the random number full for constant use. So that's why both of our dev/random and dev/urandom, they both are fast. So another command in our dev directory is our terminal devices, which is tty. So tty, so they always represent a terminal you are currently using. Okay, so what so for example, if you do echo, if you do hello me and send it to dev dev/tty, which represents a terminal you are currently using. So what you're going to do is you're going to see hello me, right? So you're going to see hello me right back at your screen. So it it is a way for a script to talk to a user even when the script's output is being sent somewhere else. So another directory that is used for our terminal is PTS, which is also known as sudo terminal. So this is one of the most interesting file in our /dev directory. So when we open up a window terminal, right, so in Ubuntu basically Genome is used for graphical representation, or connect connect by SSH, right. You are gonna be assigned a slave terminal like dev/pts0. so basically the terminal that I'm using. Okay, so if you do command wso, you are gonna see your PTS number, your sudo terminal number that you are currently using. So see, I can see SET0. so SET0 is basically, it represents a physical hardware you are touching, basically a mouse or keyboard, right. So login screen, this tells us that our graphical desktop Genome most likely to control of our physical seat. So basically it's in our seat 0, our login screen, our Genome is in our seat 0, our physical place. So TTY2, so in Linux, your graphical desktop usually runs on a specific virtual console, like here. Usually TT1 is for our boot text, and TT2 or TT7 is for our desktop. So if you do TTY, right, so what you're gonna see is you're gonna see dev/pts/0. so this is the slave PTS of your current terminal. This is my PTS current terminal PTS number. Okay, so what we can do is we can open terminal up to 10 terminal in our PC. I'm gonna open next terminal. Okay, so so our TT2 is our parent session, we can say, and our dev/pts0 is our child session. So as we did open our next terminal. Okay, just wait a second. Okay, let's go to our new, and what we are gonna do is we're gonna do echo. First let's check the sudo terminal ID first. How can we check that? So just do TTY. See, this dev/pts/1 is our sudo terminal ID. So let's do echo. You see, echo, hi, I am from another terminal. Okay, so we're gonna do this, and we're gonna send it to our /dev/pts, our previous terminal, which was this. Okay, so see, the message we printed, now we can receive in our dev/pts0, which is our original terminal. So this is how terminal can communicate with one another using a sudo terminal PID number. So so these are the important files in our /dev. There are other directory other files, sorry, as well like VCSA. So these are basically a virtual console screen. They manage text only console, and you see MC log, right. This is another file. So this is this is a machine check exception. It's a mailbox for a hardware error message from CPU. It is important only when you know what your computer is crashing, and these are only used by a kernel developer. So these are not used by a normal user. Okay, so with that we are gonna move to our next directory, which is our /process. We can say /proc. So /process. So /process is the virtual file system that provides kernel information. Okay, and process information. This does not show real file index. It is created in RAM by kernel. Okay. So why does /proc exist? Because Linux expresses internal system data as a file instead of special command. You can simply what we can do is we can do cat process, you can use any file. You can use any file that will give you the internal information of the that will give you the internal file. So this is why slash process is used. So let's see what's inside our slash process directory. See, you'll see a bunch of numbers and you'll see a bunch of files. So first we can categorize files in our process directory in two ways. So one, we can say there is a system information file, and another a process system file. So first let us understand what is system information file. Okay, so here if you come here, you will see CPU info, you will see memory info, you will see boot config, right? So these all are system info files. So let's check out some of them. So if you do cat, and we'll go to our process directory and do CPU info, right? So you'll get information about every detail of your processor. So you'll get every detail of your processor, your core, your model name, your processor, your power management. You'll get everything. Similarly, if you do memory info, MEMO info, mem info, which is a memory info, a massive detail on how your RAM is being used it will be given. Similarly, if you use uptime, this is how many seconds your computer has been since last reboot, has been up since last reboot. So these are the system information files. Another are process directories or process system file. So inside process, right, you'll see a bunch of number that we saw earlier. So see here, you'll see a bunch of number like 1, 10, 10, 13. So every app running on the computer, like Firefox, DB, SQL, every system clock, terminal, they have on folder here. So every running process gets its own directory. So how can you check is, if you do echo and if you do $, right, you'll get your cell ID. So this 4409, this is my cell ID. So how can you check your cell ID is, if you do cat and you go to process, and if you use this cell ID that we received earlier, 4409, right? If I do this and if I check the status of so I will get the internal process about this command. So basically, as you can see, my cell ID, I can get the internal information about my cell ID. So this is used by bash. You'll see status sleeping, or you'll see zombie, or you'll see termination, right? So these all are the internal information of your every command that you are using. So next files in our slash process are they are called special file. Okay, so so you'll have a file like a self named self. If you go here and if you search, you'll see you'll find a self. So it always points to the folder of whichever program you are looking for it. So if you type a command cat slash process self, right, self status, if you do this, you will see information about cat command. So basically you'll see information about cat command. Another special file in our slash process is cmd line. It shows kernel boot parameter. Another is system. So system, so sys. So process is basically for only reading the information, but in our slash process slash system, this is the only command where you can make change without rebooting your PC. So for example, if you change your host name, so if you change your host name, like if you do sudo host name, right, if you do host name, if you type a new name, so basically if you do this, then your host name will be changed. So but where will this host name be changed is, it is gonna be changed in process it is gonna be in change process directory, system, process system, host name, kernel. Sorry, in system is in kernel and host name. So basically the change is gonna happen in our this particular directory, this particular path. So basically use of /process/system is this. So why is /process important? Most of the Linux command we use is just a fancy reader like cat, like ls for our /process folder. When you run, suppose if we have a command like free h, right? So if we -h, so this is basically to read your CPU storage, everything. So this is just reading from our /process/memory info that we discussed earlier in our system information. And if we do just simple uptime, right? If we do uptime, so this is just reading from our /process/uptime. So basically /process, if you ask me, then this is arguably one of the most important directory in our Linux file system. So let's move to our next directory, which is ls/ our system directory. So while our /process was mostly it only gave us for reading information, right? /system let us to change the hardware setting on the fly in the moment. Okay, so you can so what we can do from our /system is you can dim your brightness, you can turn off your CPU, you can eject a disk by writing a value to your file. So basically every editing thing is done in our /system directory. So just like our /process, our /system is created in RAM. So like as you can see, our subdirectory in our /system is block, class, device, kernel, power. So basically these all are the subdirectory. So let's move to some of the important subdirectory. Let's move to our block. So basically this is the shortcut to all your block devices. So if we run this, right, if we do system block, so if we do this, see, you'll get bunch of loop and you'll get STA, you'll get SRO. So these are all the block devices that we discussed earlier in our /dev. So like we know STA is for our hard disks, our SRO is for our optimal drive, right, our CD DVD drive. So basically it is a shortcut for all our block devices. Another subdirectory is subclass. So it manages group device by type. For example, network configuration, input, blacklight. If we just do system and if we do class, right, so you'll see bunch of subdirectories. You'll see network interface status, you'll see input status, you'll see everything. So for example, I can check network interface from my /system/class. So what I'm going to do is I'm going to write a command cat. I'm going to go to my system, I'm going to go to class, I'm going to go inside my net, which is a network configuration, and I'm going to go, first I'll check the network interface name might be different, it may vary from computer to computer. So I'm going to check. So what I'm going to do is, as I checked, I'm going to check for my wireless interface. Okay, so I'm going to do this. So once I'm going to do is I'm going to do operate. So I'm going to check the status. See, I'm getting op. So my wireless interface is op. So another cool thing you can do from a class is, what you can do is you can check a battery percentage from this. Go to class, right, go to power supply, and go and again for this your file name might be different. Here I'm gonna use see, this is my battery file name. Okay, here I'm gonna see the capacity. So as you can see, I can see my battery percentage from here. So let's move to another directory in our /system, which is kernel. right? So this is one of the most important subdirectories. Here are kernel parameters and runtime configuration. So if we check this, one of the most important subdirectories inside kernel is probably a debug. Okay, so developer can see exactly what the hardware drive are doing. It's usually locked off for security reason, but it is one of the most ultimate debugger for Linux Pro. It is basically used by our system admin or kernel developer again. So let's move to our another directory, which is system/device. So devices. So one of the most important folder in our system directory is it is our system/dev. So this is actually the root of the tree. So everything that is inside /system, this is a symbolic link to our system/devices. What I mean is, if I do /ls/system, right, I'm getting I'm getting bunch of subdirectories, right? But everything is inside our system/dev. Our system our ls/system lys. So this is just a symbolic representation. Okay, so what is inside our system/devices? This is the actual physical map of how your hardware is plugged to your motherboard. It follows the electrical path, basically, like bus to breeze to controller and devices. Okay, so like we have discussed earlier, a call, which is a subfolder. So system/call. So this is just a filtered view for a humans. Instead of using cable, it just group things by what they are. So when do we use system/device, right? So so if we do ls system/devices, right, you'll see so okay, my bad. If I do device, so if I do device, right, I can see PCI the 0000:00, right? So inside those there are even more longer file name. This is because kernel is tracking exact address only on your hardware bus. So so if you have if in your machine you have plugged in your USB mouse and say its true path might be PCI, so its true path might be this one. Its true path might be this one, right? So that's a lot to type, right? So Linux create a shortcut for us so which is basically inside our system class. So if you go to system directory and if you go to class, right, and you can go to input. See, I can go to input. So basically your USB mouse stick that you have connected in a machine, so basically it is a shortcut for that is stored in our system/class/input. So you usually only go to this extent folder when you are doing advanced hardware troubleshooting. So basically we don't need that. So what are the importance of /system, right? So before a system existed, the process folder was getting very messy. It was full of hardware, data that didn't belong to process folder was there. So developer created /system to make it cleaner, organized map of the computer physical structure. So don't get confused between /process and /system. So /process is basically for understanding, you can think of it, what are apps doing. It is just for reading purpose. So you can /process can only answer what are the apps doing, and /system can answer what are the hardware doing. It is structured, you can read and write, you can edit, and it is clean. So basically these are the directories that are important. So another directory that we are going to discuss is mnt. So it stands for mount. So let's understand what is mount first. So what is the concept of mounting, right? In Windows, you have a hard drive which is given a separate drive letter, which is C. For USB drive it is given D, and DVD it is given E, right? So each device gets its own separate drive letter. So storage like C :/D:/E:/, they are separate, right? But in Linux we don't use drive letter. So Linux has only one main tree, which is root. We know that everything must be connected somewhere inside root. So in simple word, you can understand it. Take a storage. So basically that's the most simple way can understand it. Okay, suppose I'll give you, suppose you have you have plugged in your USB drive. Okay, so Linux detect it as dev/sdb1. So Linux detects is as SBD or SBA1. So but you cannot use it yet, because you must attach it somewhere, like you have to mount it. So to mount, you have to run a command which is sudo mount/dev/sda1/mount. So once you mount it, you have mount your USB to our /mnt. So so now you can only access the file which is in your USB, and you can access through mnt. So instead of drive letter like de, we only use /mnt. Okay, so I'll give you a more clear example which is now. So you have a USB which has a photo, right, and you want to access them. So you insert inside the port. So Linux detects it as a, so wait, see, Linux detects it as a dev/sd1, but at the point you can't see the picture, it is inserted, you can't open file, it's just a raw device, right? But now you mount it, the command we discussed earlier, you mount it. Now your USB file system is attached to our /mnt. Now you can, now if you do ls/mnt, you will see your photos, you will see your videos, you will see everything. So in Linux there is so like mnt, there is another directory that works automatically, which is media. So if you do if you go to our root directory, you will if you do ls/root if you do ls root directory, you will see another directory which is known as media, right? So the working principle is same as /mnt, but it is automatic. So suppose you plugged in your USB, right? Your program called a program called udix sees it and says, oh, user just plugged in a USB. So it automatically hooks it to /media/user, your user and your USB, and you can access your photo. So so why we use mnt then? So if media is automatic, then why we use mnt, right? So you use it when you want the full control of a your USB stick. Suppose think of it as your system has broken, right? So you want your computer won't boot, and you install your live USB to fix it. So you would mount your broken hard drive to /mnt to rescue your file. So it is used in that scenario. So it is used so suppose you are using a secondary drive inside your PC that stays there forever. You might want to mount it, and you don't want that storage to you want that storage to be in the same place. So for that reason, we're gonna use /mnt. For more clear example, think of it that you have forgotten your password, right? You are locked out. So you are locked out of your computer, and you boot from your live USB. You open terminal and find your hard drive, right? Using lsblk that we used earlier, we mount our hard drive to our we mount our hard drive to our live USB. So we're going to use sudo mount dev, so that command that we used earlier. So once you do that, we use the command chroot /mnt. We use this let the computer to trick that into tricking that. It lets the computer to think mnt is a root, and now you can type password like pvyd, and you can change your password from your broken drive. Don't get confused on this particular command, which was okay. I'll write the command sudo mount. This is one of the most important command if you're gonna mount, right? So please don't get confused in this. Sudo mount /dev/sd1. So basically what you're doing is, if you're inserting a live USB, right, you are mounting your broken hard drive to our /mnt for recovering your password only when you trick your computer that is /mnt is your root user, then you can use a password. Okay, again the command is same for your live USB and your normal USB. When you are accessing a file, when you are using a normal USB for accessing a photo or file, you are mounting it into your MNT, we are mounting it to our hard drive MNT. But when we are using a live USB, we are mounting our hard drive to our /mnt. So this is why we use MNT and /media. They both have their own purpose. So these are our complete Linux file system. Okay, so everything that I've discussed, every command that I've written today, and part 1 in part 2, everything is in my GitHub. I posted my handwritten notes. If you want to learn in detail, then the link of my GitHub is given in description. Okay,